Good morning to everyone. So this is I will presenting the course preview for the Certified IoT Specialist course by iTrain. So I will just introduce myself first. So my name is Yap Wen Jun. I am currently lecturing in MMU, Cyberjaya. So my subjects are mostly engineering mathematics, which focus on mostly numerical methods. And I also lecture about mobile app development and supervise a lot of capstone projects. And most of them are IoT related. Okay, I'm also a co-founder of iSparks, which is a MMU spin-off company providing smart parking solutions. And since it's IoT related, I would sometimes I would take example from the startup. Okay, so let's look at the learning outcome for the course. Okay, so I will be very brief because we will go into each module selectively and have more, so that actually you can understand more on certain topics. Okay, so we'll explain what is Internet of Things. We'll understand how they are all connected together and provide the data. And we'll learn about the protocol used by all this. And the protocol here can mean many level, okay? So from the lowest to the middle layer and so on. And we also will actually learn about the challenges. And lastly, once you have the data, what do you do with it? So we will do analytics. And if you follow what Dr. Nick and Dr. Alvin have mentioned, it's actually including all this analysis with the data science. Okay. So let's look at let's just go through fast the course outline for all 3 days. So it's a 3-day course for this IoT specialist course. So you actually will have you can download this from the iTrain's website, the course outline. Okay, the first day will focus on mostly the lower level, the sensor, the hub and the architecture and all that, and the low level communication. Day 2 will go to the cloud. Once the data go to the cloud, you start to do analysis. And finally, the day 3 more like integration and a lot of other considerations such as security and so on. Okay. And the end of after you have completed the course, the exam format will be 1 hour, 30 questions of MCQ, and the passing score is 70%. Okay, the passing score of 70% is actually not difficult at all if you pay attention to the course. And at the end, you receive a professional certification after you pass the exam. Okay, 70% from the 30 MCQ question. Okay, so I will also just briefly share about the prerequisite listed in the course outline. Preferably 2 years of experience in software development. Okay, because there are some programming in the hands-on, and business you can also have 2 years experience in business domain and also data analysis. But if you really have no such experience, you can still consider taking up the course. Okay, because even the programming part is actually quite basic, which actually you can see from some of the slides later. Okay, so who should attend? I wouldn't read all this, but this is not the exalted list. Actually, I would say that actually any graduate or even undergraduate or anyone like that actually is interested at this IoT, which is a huge thing, you can attend. Okay. So let's go into the introduction of IoT. Okay. So what is these are the subtopics inside, and we'll go to the first one, which is the definition of IoT. Okay, if you follow you read online, you read magazine and so on, the definition of IoT is actually quite diversified, quite broad. So actually, we'll just but the basic idea is the same. Okay, IoT stands for Internet of Things. It's the ever-growing network of physical objects. Okay, This is the first keyword, is a physical object. Okay, can be small, can be huge, and they are connected to the internet. This is the second keyword, is connected. Okay, you have things that is connected. That is actually the brief idea of the Internet of Things. But of course, you have to also focus on why do you connect them? Okay, once they start to communicate, you can see that the data can be transferred between these things and also go to the cloud. The cloud here is actually what we rely on our daily life for quite some time now. You can do most things from the cloud. And now once the data from all these things go to the cloud, right, it opens a lot of opportunity to either do analysis or actually can start doing things a lot of things automatically. Okay, the IoT is predicted to bring more than 30 to 50 billion connected devices online by the year 2020, and these data are huge. And actually, from the previous presentation, you know that the more the data you collected, actually the better your analysis will be done. Okay, so let's look at some example. These are some are related to Malaysia market, some are not. For example, the first one, the thermostat, which is actually a huge thing in US, where actually most of them actually has a smart thermostat at home, including the one from some of the branded company. But for here, probably we'll just maybe start to implement like smart air conditioning. Okay. The second one, the connected cars, is also start to. You actually can see that actually once you connected so many cars together, there's a huge data coming in, and now the thing that actually is connected are mostly those rental company, where you actually can use you can download an app, look for car rental, you search, you can book a car, and then you can just travel. You go to the place, you use your app to unlock the car, you can drive the car, and they start charging you. Okay, so these are already happening, and lastly, the last one is actually the parking solution, which also I think are already implemented in certain place, and the startup actually which I'm joining also actually involved in this particular solution. Okay, in this case, the idea is actually you actually need sensor to detect where are all the available parking slots, because I think you have of course these are in this moment most people just stay at home, but once the restriction order is lifted, you actually will know, you probably will go back to the experience that actually it's so difficult to find a car park. Okay, and there are solutions actually trying to solve that. You have sensor detecting all the empty slot, and the data go to the cloud. Your app connected to the cloud, you actually can book a space, or actually you can just go to the place intelligently. Okay, so now we look at the various domains that actually you can have all these IoT applications. So these are some examples. Some are actually very small scale, but some are actually very huge. Like the first one, the utility, the electricity. Okay, what we have at home now, all the electricity meter, such as all installed by our Tenaga Nasional, are actually not smart at all. They are probably mostly just analog. Okay, so but once you actually connected those meters and make them smart, actually you can do a lot of things. The one we're actually talking about is a smart meter. Okay, where actually you can record not only the wattage and the currents you are using at a home, and it also can start using all these a deep learning tool that actually can start to predict, okay, what we call that, the appliances that actually are not efficient at your home, and you also can see that actually this can support what we call the smart billing, the flexible billing that actually at certain time when you want to use your electricity is actually cheaper and so on. Okay, this will be possible if every home actually has a smart meter. Okay, we can go to other domain. The one that actually are very related at this critical moment now is the healthcare. Okay, where actually you can connect a lot of sensor that actually can start monitoring. Okay, this is one example that actually is, I think, is very relevant. Where actually you have elderly. So for example, now since you are restricted to visit them regularly, where the elderly that actually you probably need what we call the IoT system to start monitoring their health. Okay, what you can see a room that actually, a house that actually where you install a lot of sensor, either intrusive or non-intrusive. Intrusive is the one that actually the user actually need to wear on them. Okay, can be a wristband, can be a belt and so on. Okay, and you can also have non-intrusive ones, such as I think you can start measuring temperature even from certain distance using infrared, and you also can have vision, which is like infrared or not infrared, just a night vision enabled camera that actually can monitor them, especially their movement and so on. Okay, once you detect they need help, you actually the IoT system will actually do all this automatically where if they detect they need help. Okay, the smarter, the more data you can collect, the smarter the IoT system will. So that actually you can eliminate all the false positive or the false negative. Okay, so the last one actually I would like to look at is the smart city. Okay, the smart city is like you said, the smart parking is one of the aspect of that, and which actually you can see from there. Okay, but that's not the only one. You can see that actually the utility we are using for the city is actually huge. Like you want to monitor all the lampposts, all the traffic light, and so on. So that actually it's a big increase of our GDP that actually by doing a lot of saving, because of you actually definitely no need to on certain lampposts in certain area. Okay. So let's go to the second module, which is also in the day one. Okay. So this is the one that actually this is the one actually I would assume that some what we call participant that actually will kind of worry that actually they cannot cope. Okay. The low level part that actually like the architecture, the technology and the protocols involved. Okay, so the architecture here, we will just look at one of the basic one, very basic one. Okay, so you actually can see that when we talk about the Internet of Things, what are those things? Those are all the devices. Okay, and in this case, right, let's focus on the sensor first, because I think sensor is the one actually you can measure all this physical quantity around surround you. For example, the temperature, the humidity, and so on. We actually will have more slide on them later. But you can see that actually now, right, all these devices will actually have to be connected. Okay, and the most efficient way is actually, if let's say you go back to this scenario, that actually you have a house where you have all this remote sensor being installed in various rooms. Okay, so now you would like them to actually send all the data to a so-called a hub, okay, or a gateway that actually will collect all this data, and there should be some intelligence of that inside this hub that actually they will decide, okay, what data are important and how frequent I will have to upload all this data, go to the cloud. Okay, this is the first layer of usually when we are talking about the IoT. Okay, the technology involved, you have look at it in the next slide. And the next one is actually, once the hub getting all this information from all these devices, he will actually need to send them to the cloud. Okay, so the cloud here can be private, can be public. Public means like Google, Amazon, and so on. Private is probably the one that actually you can set it up yourself. Okay, and the data ones go to the cloud. This probably is also rely on the stability of internet and all that. Okay, once it go to the cloud, what can be done with all this data? Okay, firstly, there will definitely be stored. the data will be stored in a database, and the data will be able to be retrieved and queried later. Okay, because you actually want to have all this historical data. The huge historical data is actually what makes some of the analytical work. Okay, all this data will be analysis and also can be visualized. Okay, the visualization can be done through a web app or just a mobile app. So which you think you see there. Okay, this actually almost complete the flow for most of the IoT project. Okay, you have device, you send to the gateway send to the cloud store them and analyze them. Okay, after that, what can be done is actually depends on the particular project. Okay, sometimes they can the analytical tool or the online cloud can just based on the analysis or just certain data, he actually can automatically sending out command where the command can send to the hub and do something. Okay, and it can also be done that actually let the user decide what to do, which actually you can see here. The user actually can trigger command after they look at the data. Okay, so now let's look at the particular technology and protocols that actually we'll learn during this course. Okay, so you can see this is actually, if you look at this diagram, it looks complicated, but it actually is very similar to this. It's just that actually now we put in all the technical term inside that actually that's the technology and the protocol we are talking about. Okay, first actually you see that the sensor here is the one actually is when everything starts. You actually need to collect data from the world so that actually you can do something. Okay, this sensor will actually start sending data to the gateway. And why do we don't send the reason why all these sensors are not sending directly to the cloud is for economic purpose. Okay, it will just not be very feasible for all these device or the IoT device that actually has the processor power or the networking capability that is good enough to actually directly connect it to the cloud. Even though it's possible, it's not economy. Okay, there is more effective. You actually have a gateway in between that actually can selectively sending the data to the cloud. Okay, and it also depends on how frequent are those data being collected. Okay, what are the technology here we are talking about? You can have Bluetooth low energy. You can have them connected through data serial cable and so on. Okay, we'll have a look at all this technology. And the gateway here, we actually have a look also what are the possible candidates to use it. Is it a computer and so on, or just a mini computer and so on? Okay, this gateway will actually start you connecting to the cloud, and the protocol to send also you have choice. Okay, the common one that actually a lot of web expertise can use is the HTTP. Okay, but there are other efficient or more effective ways such as the Constraint Application Protocol or the MQTT, which is kind of become quite popular currently. Okay, once this data go to the cloud, it will probably need to be stored. No, sorry, it's not. It has to be stored. Okay, it's just that actually which type of storage you are going to use. Okay, the traditional relational database such as the one you already hear is like MySQL and all that. It is possible, but it depends on your volume. Okay, if it's a huge data, it probably is a better idea to use something that is called NoSQL, where it's non-relational. Okay, we will have a look at those. And finally, the data will be, what can you do with the data? Okay, you can do visualization. You have very nice cloud web app that actually can visualize the current data or the historical data. And also you actually can do automation using rules engine. You will see, you heard a lot of this, the word rules engine here. They technically are rules. The rules is something like this. If this and this value are more than this and this, you should do this. That's the rules. Okay, or it can be combination of multiple rules. If A and B happen, can you do C? Or if C is failed, can you do D and so on? So these are the ones that actually make the system a bit smart. Okay, And all this now can involve a user or none. If it's all automated, actually this user part is actually just for visualization. But of course, you can always send alert to the user and let them have the power to actually trigger action. Okay, so the action, what kind of action, which actually is the part here actually is the same, is the things also, but these are not sensor. These are what we call the actuator. These are the one that actually do things. For example, I think you can see a robotic arm here. Okay, so let's say if the action is to pick up something, so the sensor detect there's something there, it send to the gateway go to the cloud actually send to the user look at it, oh actually we have to pick this up, so they will just trigger the robotic arm to pick these things up. Okay, this is the one that actually do the action. And finally the last part actually this is a very broad category, and we probably will just briefly discuss this in our course. The user interface layer here include web app or mobile app, and the technology can be just most web app platform, and also maybe Android or iOS. Okay, and let's go to the things, which is the 80%, I think, maybe more, maybe 90% of the things actually is sensor. Okay, the sensor. So what is sensor? Okay, so you can see here, sensor link the physical world and electronic circuit by producing an electrical output in response to a physical quantity. Okay, so if you're not clear, let's take a first example of the first sensor actually you see in the slide. Okay, there are 4 here. Some of them you probably can't tell what is it. For example, the third one, right? I look at it for quite long, then only I noticed this is a touch sensor. Okay, the first, let's go back to the first sensor. The first sensor is a infrared distance interrupter. Actually, it's actually quite simple to understand. Okay, you can see so that actually you understand how actually sensor work. You see the blue cube here. There are 2 things inside. One is an infrared LED. Infrared means actually technically our eyes can't really see. Okay, but you probably can detect it using your camera of your phone. Okay, most of the camera phone actually can detect infrared. The one near to the light. Yeah. Okay, this infrared LED, and there's an infrared sensor there. The infrared LED will continuously emit the infrared light from the top here, and once you put something on top, such as the object that actually you want to detect, it will actually reflect the infrared back to the sensor. So the sensor will convert the light actually reflected to electrical signal. Okay, now you actually can go back to the definition and see that it actually is just something that convert a physical world value to a electrical output. Okay, so physical here means the infrared being detected back and it produces an output. So what does this sensor actually function as? So you can see that if you put it on a conveyor belt, like you go to eat sushi, the belt that actually moving around, and this is actually probably can also be used in the sushi store. Okay, you can put the sensor on one of the entrance or the exit of the belt, and they can just start counting how many objects are passed by. Because any object passed by, the infrared will be reflected back to the sensor, and the electrical signal changes will actually you can detect it, you can process on it, and you can tell there's one object being passed by. Okay, so actually you can start go to creating how many sushi are being eaten every round and so on. Okay, so now next is let's go to the type of sensor that actually is actually common or useful in certain scenario. Okay, so you can see this diagram. The reason why they put the colorful rainbow there is actually just to give you an idea. There are various spectrum of sensor that actually you can use. Actually, anything that actually you can think of, right? There probably a sensor can detect this. Okay, so for example, one of the sensor actually I didn't know exists is something like like you can detect the water level whether it's flood or not. Okay. So now let's look at one of the one actually you see inside the first slide. Okay, which is this one. This is just a GPX. Okay, the right side, the gray color here is a GPX sensor. Okay, so even though it doesn't really fit the one actually you put it here like the infrared sensor, because it doesn't really convert any physical quantity to electrical signal, but it does do something. Okay, so it receives GPX signal from satellite and convert it to a location. Okay, so technically it's still a position sensor. Okay, the position here, and the object detection here also is considered similar. It's just position sensor. Okay, so this is the one actually detect position, presence, and proximity. Okay, one of the quite useful one. Okay, because you can tell actually if it's a motion sensor, you actually can detect whether someone is illegally going into your house. Okay, so next is the one actually so if this is this is usually the one I like to demo, the bottom here. Okay, the top one is just a regular temperature sensor. The temperature go up and down, the voltage go up and down, because the temperature will change the resistance of the resistor there, and therefore the voltage go up and down. Your mini computer can detect the signal, the voltage change, and convert to a temperature. Okay, similarly, the bottom one is also the same. It's just that the bottom one here, the white color one, which actually you will see, I actually will show it on camera. Okay, this will be also can detect the humidity. Okay, it's like you can create your own weather station at home. Okay, and I'm blocking myself, right? Okay, let's wait for this is a air quality sensor. I have used this in a project before. The air quality sensor is actually can detect you remember actually like certain months our country is always covered by haze. I hope it's not going to happen again. But because of the haze, you actually always have to look at the side, or what is the API now? Is it like 200? Is it dangerous or not? Remember the haze? Okay, the air quality sensor is the one that actually can help you monitor that even at your home. Okay, so actually this is the mic, the thing that look like mic there, right, is actually a sensor. Okay, it heat up. There are substance inside that actually interact with the air pollution particle that actually can convert to electrical signal. Very interesting sensor. Okay, and lastly, camera, which actually the one you're using now to look at me. Oh, sorry, the one actually I'm using to let you look at me is also very useful now because of all the image processing we can do. Because of all the deep learning tool we have. Okay, this is actually a slide from my my startup parking solution. You can see we can use a webcam, can detect a smart parking lot, and you can tell actually which lot are empty and which lot why people parking illegally in a lot that actually you are not supposed to park, and so on. Okay, these are so if you have this installed, actually not only actually it will make very convenient for user to look for a parking space, it's also very useful for the MPSJ or the Shah Alam council to actually go and just summon all this illegal parking. Okay. So finally, we also will show you one of the concept of sensor, which is a wireless sensor network. I think you actually see that actually farming. The smart farming is also one of the main technology actually we should for Malaysia. Malaysia actually has a lot of farmer, and you can see that actually once you actually install, I think you can see the small solar panel and the small module under there. These are all the sensor. Okay, but this sensor can be installed in such a big area of farm that actually it become not feasible to do something like this. Let's jump back to the slide, such as this one. Okay, it become not feasible to do something like this if you have so much sensor in a big area. Okay, And there, because they are just too far away from the gateway, okay? And there are just too many connections that actually you need to establish with the gateway. And therefore, actually, there's this thing called wireless sensor network. That actually, you can let the sensor hook from one place to another. All the sensor here, okay? You can see one sensor is just connecting to another sensor and then connecting to a few more sensors and so on. And they start to creating a mesh network, what is so called, okay? So this is a very efficient way to deploy to a very huge area. And this is the one actually can collect a lot of data to be analyzed, okay? And lastly, it's not really a physical sensor demo. I'll probably just show you, because it probably, I'm not sure. Let me try. Can you see the sensor on my camera? Or actually, I need to stop sharing now.
We can see also on the right-hand side.
Is it too small? If it's too small, I can temporarily stop sharing, right?
Yeah, now we can see it better. You can put it a bit more up.
Okay.
Right. Now it's perfectly seen.
Okay, I need to go back to my. Okay, this is okay. This is a sensor. You can roughly see the size here. Okay, this is a temperature and humidity sensor. Okay, let's go back to the slide. I hope I don't mess up again. So can you see the slide now?
Yes, we can see the slide now.
Okay, so you can see this sensor will actually convert temperature and humidity of your room to electrical signal. Okay, so this is probably scary for if you are non-technical, and especially when I show you the program. Okay, you have heard from the previous speaker also. Is it hard to do programming with Python? I would assume actually you probably correct, according to him is correct. You need at least like 2-3 days to actually learn the basic, like what is the keyword and all that. But you can see that actually with the software library provided by most of this hardware, right? The programming is actually not difficult at all. Okay, so you can see once the library is you found the library, you actually can connect the sensor detect, and then you actually can collect the data from here. Okay, you can see actually. Can you mute this? Okay, so the software, the software actually is mostly are just you probably have, like for example in this case, let's say you want to do a project of the weather station at your home. Okay, this is almost done now. You actually can get the value from the app already. Now you just need to make sure how to upload this data to the cloud. Okay, so now this is some example of the result sent by just execute after you execute this script on most likely a Raspberry Pi. Okay, so these are the value and so on. Okay, so now let's continue to still the day one module of the world. Okay, because we actually like to show you the hardware platform. Okay, so these are some of the hardware platform that actually here, right? This hardware can either behave as a device or actually the gateway. Okay, some of the popular one is like the one you saw here is the Arduino. Okay, the Arduino, the one in the slide is actually quite an expensive one that actually have Wi-Fi capability. The one you see here actually is, I hope you can see also, a very small one is actually one of the most popular embedded device that actually all my students are used to do project. Okay, they connect to the sensor, they can upload data and so on, they can process the data and so on. Okay, the next one actually, which is also one of the what I think is actually what a great invention done by the company. Okay, the Raspberry Pi. Okay, the one you actually saw, I already connected if you remember just now, the sensor. That's how you connected to I hope you can see from the camera, but how you connect a sensor to the Raspberry Pi. And this Raspberry Pi, which is why I say it's actually very, what a great invention is because it has a very good processing power and it actually small and it's not that costly for what it can be done. It's actually just a small computer that actually you don't even need a fan, okay? So actually it's actually very low power. And what makes it so different from your laptop or desktop is the 40 pins there, which is how you're connecting to the physical world. You can see the pin being labeled here. Some of them give you 5 watt, some of them give you 3.3 watt, some of them connecting to the ground, and most of the pin actually you can talk to. Okay, so this pin is the one connecting to the sensor, can read the sensor value, and now you can start programming. Okay, so now let's look at the almost the last part, which is the cloud. Okay, so once you have your device ready, your gateway ready, and now you actually need to upload or actually send them to the cloud. Okay, what kind of option you have? Okay, just I actually will present all three of them and roughly show you actually what are their strengths. Okay, this is from the Amazon. Okay, you can see that actually they're focused on how to connecting to their existing services. Okay, so the Amazon Web Services actually a lot of people using. So their IoT platform can integrate easily with their AWS service. And one more thing that actually you can see a lot of them focus is the security. The security of the IoT device here actually is usually not the first priority when, let's say, my student do the project, or even when we start doing prototype as an idea. But it's actually very critical. Okay, if you watch I forget which one of the Fast and Furious, you actually remember or not, all the car that actually smart are connected are being hacked and actually become a weapon, where they throw all the car from the building, high-rise building to the ground. Okay, this is possible. This scenario is actually very scary, where actually all the connected device can be hacked and being can harm people. Okay, so therefore the security part is actually very important. We will look at them, and you can see Amazon also will actually focus on them in their IoT platform. You can see that actually all three of them actually focus on this security a lot. Okay, so now you also can see Amazon have also their own rules engine, and this is from Google. Okay, Google their IoT platform kind of diagram actually will similar, the device management, the security, and you can see actually Google actually use MQTT instead of HTTP, and you can see that the main, I think, Google strength is search. Okay, therefore actually they focus a lot on this big query, and they have their own data studio that actually can do analysis. Okay, and last one, I think this is Microsoft. Microsoft also, you can see the similar thing. You can see the what we call the security part, which is how to handle all these device provisioning and so on. Okay, and also the Microsoft of course focus on their business, which you can see here. They actually have their own machine learning, and actually Google also have the same because of the TensorFlow. TensorFlow is actually a good deep learning tool that actually you can use to analyze your data. And Microsoft has their own, and also the business integration with all the existing Microsoft other platform. Okay, and this is from Mimos. Okay, our own locker invention. Okay, you can see it also have the similar architecture. You also have the security part, the rules engine, and so on. Okay, so what's the difference of this? This one is actually you can do your own cloud. Okay, so which means that you can just get a local PC, connect it to internet, and install this Mimos get this cloud platform on the PC. You have your own cloud. Okay, why do you want to use your own cloud instead of actually using all these existing public cloud such as Google or Amazon? It depends on your requirement, because certain projects actually are high risk or high security. You probably actually don't want it to be on public cloud. Okay, And also there may be rules, actually, if this is a government agency, it's actually probably actually make sure the data are reside in Malaysia instead of somewhere, don't know where is all the cloud server being reside. Okay. And lastly, this is the day 3 module that actually about brainstorming on opportunity and how they can be realized for future. Okay, so let's look at the large IoT market here. You can see the market also, they make it by layer, actually, which is very similar to how we cut the cost to actually layer by day. Okay, the lower layer, which is almost related to day 1, and the middle layer and so on. But you can see the most of the market is the last layer. Okay, the analytic and all the app and services. Okay, 80% of the market is from there, and you can see the projected value is actually huge, 34 billion ringgit Malaysia, and this is predicted in 2014 by Gartner. Okay, but you cannot neglect the other layer also. So if you're a hardware company, it's probably actually is not bad to actually invest in the Internet of Things that actually you're really good at doing. Okay, which is also projected to have at least 4 billion of market. Okay, and the global IoT market will grow from 157 billion in 2016 to 457 billion in 2020. This is also forecast, and this is a growth of 28.5%. Okay, IoT has the power to change the world just as the internet did. Okay, maybe even more so. Okay, so I hope everyone will have learn. If you manage to learn and apply all your skill of IoT that actually you've learned to involve in this trend. Okay, where actually just make the world a better place with IoT. Okay, especially in this current kind of critical period. Okay, so I think that's all for me. Now I think we can go to Q&A.
Yes, thank you very much, Lanjan, for the presentation. So the first question that we have is whether a person needs to have knowledge in electrical engineering or IoT first.
Okay, let's don't go to this. Let me see. Okay, whether you need electrical experience when connecting to the IoT. Okay, first is there are multiple options you can have. Okay, you can see that actually the one I show where actually you get the sensor directly. You get your sensor. Okay, I know I need to do. I stop sharing. Okay, so you can see that the sensor, like I showed just now, where you actually bought it directly, you probably need a certain experience is connecting them to a cable, what we call the cable, like this one, which actually you can see, okay, in the camera. But there are sensors that actually being you can buy. They are just plugged directly to the hub that actually you can also buy together, which means there are certain options. There are products that actually the gateway come with all these sensors connected. Some of them are just, so for example, there are products that actually you get the gateway, you connecting to your LAN cable, you do some certain setup, you go to the cloud, and there are QR code that actually you can scan. They will pair all these device, the sensor to the hub directly, and that's done. Okay, in that case, right, you actually don't even need to do any single line of programming or even do any configuration at all. These are just the more refined product of IoT package. Okay, but if you really want to do a low cost one or actually more economic one, such as you get your gateway, you get your hardware, you want to connect them, and you want to set it up to connect to the internet and so on, you probably need a skill of a bit of electronic and Arduino, and for example, and how to use Arduino, and also some certain level of programming. Because even though with library, the programming are very simple, you still need to understand how to modify them. But to be honest, I have given course to kids or secondary school students, and also for public people that actually doing on the using Arduino to connecting to all this. It's actually they can do it also. So probably with 2 day of learning, you can do it also. Without any prior experience in electronic or electrical engineering.
Okay, thank you very much for your answer. And the next question is it possible for a programmer to understand IoT hardware?
I think because of the programming nature of it's actually quite it's already the programming of the IoT is a lot less complicated than your regular programming. Okay, because you get the idea. The reason why you need to program is actually to get the data from the sensor or multiple sensor and put them into the cloud. Okay, all the library are already there, so the programming part is probably done. The hardware part, which actually you take the sensor and you have your maybe Arduino or Raspberry Pi that actually want to connect. Most of the time, the device that you buy actually has a very good tutorial with diagram nicely. So let's say, for example, the one you saw just now, there are very nice diagrams that actually show you should connect to which pin of your or Raspberry Pi and so on. The only problem is actually if you start getting the one that exists not being showcased in the tutorial, then you actually need certain like how to, because you have to tell actually how to modify slightly the connection, and also whether the device you get now, does the voltage match or not. For example, if I use Arduino, and most of them can take 5 volt kind of input, but if you change to some certain board, right, it probably cannot. Okay, then you actually need to create additional components such as a resistor and so on. Okay, so there are options that actually you don't have to do many things. There are also options that actually you really want to go and get a books on electronic and learn the basic of even setting up a circuit with resistor. Okay.
Okay, thank you very much for your answer. And the next question is whether working with Raspberry Pi considered an IoT project?
The IoT project here, of course, you can see them from the diagram before. There should be some things that actually you're actually connecting to your Raspberry Pi, or the Raspberry Pi itself is a sensor or the actuator. Okay, a Raspberry Pi has actually very little sensor inside, so probably you need to install something called a head. Is a additional module that you can plug into the pin there. Then it actually can do like sense something. Okay, then actually because the good thing about Raspberry Pi is actually has BLE, the brutal low energy already built in. It also have Wi-Fi built in. So once you can connect BLE device to it, you can connect Wi-Fi to it. It can connecting to the cloud, and you are sending data from the Raspberry Pi to the cloud. It's kind of already an IoT project, but once the data go to the cloud without doing any data analysis and so on, it doesn't bring you anywhere. So you probably still need to have an analytical tool or actually visualization tool on the cloud. Then it's more or less an IoT project.
Okay, thank you. And now a statement made, and you'll have to correct if the person was wrong, is if RPI pervasive. So if the project implements connectivity via internet, so for example, fire alarm warning to Twitter, is it IoT?
I will it actually match the definition of IoT. You have value sent by sensor, and then it go to the cloud. It still fall in the domain of the IoT. Okay.
Okay. So, as it's possible to store data on the cloud, is there any specific software app to do so? The person is working with moisture sensors.
There are so many options. Okay. So, for example, the first thing is moisture content, I think, is not very critical or very security related. So you probably can use the public cloud. And the public cloud also, there are local company offer them, and there are also the global one, such as Google and so on. So once you have data collected in your gateway, those gateway will actually do a HTTP, or for example, you can see you can also do MQTT and upload this data to the cloud. The cloud actually depends on which one you use. Like if you use the Google IoT platform, those data will just go to their existing the big table. Google use big table to store data, and how they store those data, you actually have you don't have full control, and you just trust them, and you can easily retrieve them back and so on. Okay, and so therefore actually the tools, if you really want to do yourself, if you really want to do your own private cloud, where actually you have to install the server, you need to write your script, and you need to set up your own, whether you want a relational database such as a MySQL. That means you have to install your MySQL into your cloud, and or you can use a NoDB, so NoSQL database such as a MongoDB, but you also need to set it up yourself. So I actually not so sure what are the choice you have to make, because it's actually very depends. So actually, if you if there are more details, maybe I can answer more clearly.
Okay, thank you. And another question is whether CNN is included in your training course for image processing.
In this course, the image processing portion is not even in the course. Okay, but if you talk with me, of course I can share my experience. The smart parking solution you saw I shared just now is using CNN. Okay, and but to be honest, that I think iTrain has deep learning course also. You can probably ask ask Elizabeth.
Okay.
Is there a deep learning course?
Yes, there is a deep learning course that I train, and more information about that can be found
Okay.
on the website. Yes, so another question to you is, what type of security would you recommend for the things in IoT?
This is a very, very, very broad question based on your scenario. Okay, for example, let's look at the higher level where actually we use the public cloud. Public cloud, because of the way it's being set up, let's say you use Google or use Amazon, the security are already enforced. So actually, it's where if you trust them, you trust Amazon, you trust Microsoft, you trust Google, the security is already implemented. Okay, that one is done. Okay, now go to the private cloud. The private cloud, actually you need to set it up yourself. Okay, so which part actually you scale up the security? So if you the point of intrusion, like let's say people want to hack your system, is the cloud is actually has all these tools, like you actually can just install. For example, firewall for your PC and so on. Those are, you can use existing tool. Okay, and when you start scripting, right? Let's say you use Python, or you use depends on which one you set it up for your private cloud for the server. Okay, Python, you just follow the security aspect of Python scripting on the cloud. Okay, this will be sufficient. Okay, that's the cloud part, because it's just a regular server. Okay, how you protect your all other web server, how you protect your cloud. Okay, now we go to the lower level one, where the things that actually is being connected. Okay, if you are using Wi-Fi, you actually of course need to set it up like the regular. Please do not use a no password or just the regular WEP password and all that. That's just not sufficient. You will just still protected your Wi-Fi as if it's a very secure Wi-Fi. Okay, even though they are connected from all these small device, that actually you will find so convenient. I just use a no password configuration. That's not a very good idea. And also, let's say certain project that use BLE, the brutal low energy. Brutal low energy is not really secure if you don't do anything. Okay, because all the device just keep on advertising, and you can just scan for them and try to connect to them. And if you start to know that which actually value give you value, which byte give you value, you actually can hack it. So then you start to need to see how do you secure your BLE IoT device by looking at the what we call the encryption, the end-to-end encryption, that actually you just don't let people see what are being transmitted. Okay, because you really don't want people eye draft on all the data you are transmitting either locally or from the gateway to the cloud. Okay, if you need more answer, you can just ask more specifically later to me, and I can answer.
Yes, thank you. So there are more questions. As you mentioned before about mammoths, they encourage Africa to build their own cloud so that the data resides there. The question is whether the cloud options they have for a beginner to start a project. So what are the cloud options for a beginner to start a project?
If it's a beginner, which actually all my students are when they start doing project, I'll probably just ask them to use the most what we call convenient, because you probably just want to store the data first. Okay, because once the data are being stored on the cloud, you can retrieve it later and so on. So for example, even though of course I myself is from Google Developer Group Kuala Lumpur. So actually you can see me all like almost, why is it always promoting Google technology? But there are actually very convenient to use. For example, you have your local, let's say you have a sensor already connecting to maybe Arduino or Raspberry Pi that you actually want to push to the cloud. The Firebase real-time database is one of the very easy to follow and start kind of project. Okay, I actually what we call, most of my students have no problem doing their first project that way. The Firebase real-time database. Okay, of course you actually need a Google account. You need to sign up and start looking at the tutorial of how to set it up so that actually you can start getting data from your local hardware.
Okay, thank you. And the last question is, apart from Python, what other language can be used for IoT setup? Why use Python?
The reason why you see the Python as an example is because it's the most common programming language in Raspberry Pi. You have seen the Raspberry Pi, which actually the one you saw on the camera now. There's a reason why is it called Raspberry Pi. The Pi part is actually Python. The board are just so set up to so conveniently support all the Python programming. Okay, and there are so many libraries. For example, you saw me showing you this what we call this sensor. The only sample you find on the official tutorial is in Python. Okay, if you want to do it in other language, you can. But now you need to start looking at their Python library and looking at their code and actually port it to your own programming language, which is possible. You can do Java on Raspberry Pi. You can do C and C++ on Raspberry Pi. You can also do something what the previous speaker has shown, visual programming. The visual programming for the data science, of course, is different from on the Raspberry Pi. On Raspberry Pi, you can use something called Scratch. Is it correct? I think it's called Scratch. It's also a visual programming that actually is the same you saw just now. You drag and drop like Lego blocks and connect them. You actually can connect to, there are modules that actually let you read the sensor data and actually have modules that actually let you upload them to the cloud. Okay, these are all options. And also, if you are doing something else, right, such as using Arduino, the programming language is different. The Arduino use their own C-like programming, okay? And if you have a Wi-Fi module on the Arduino and also an Ethernet module, you also can just use that directly and send to the cloud, okay? And it's not, there's no limitation, there's no limit. You can do any programming language as long as you can install them on the Raspberry Pi or any other board. We just don't, maybe I should not just say Raspberry Pi. Any actually IoT device or gateway that actually you can install a programming language such as, for example, Node.js or even, there are a lot of funny language that actually you can use.
All right, thank you. That was, that was the last question. Thank you very much for presenting and for all the answered questions.
Okay, thank you, everyone.
Yeah, so thank you all for attending and staying until the end. For those who are interested in getting the presentation, please fill out the feedback form to receive the presentation. You can find the link also now in the chat box, or you can scan the QR code, and we'll be shortly sending you the presentations. And yes, so if you have any more questions about iTrain courses, either in data science or IoT, you're more than welcome to access our website, www.itrain.com.mi, or send an email inquiry to info@itrain.com.mi. Yes, so thank you very much for attending, and